Hi, I'm Rody, and today we're going to build a node-based editor with Signals, which is a library that I just recently created. Hopefully this will serve as an example on how to build a pretty complex state problem that would be difficult to do with some other solutions. This will involve circular dependencies, disconnected state, and dynamically updating values, while being able to have a simple, easy to show diagram and having it all connected together. We're just going to be using the Signals package and what Flutter provides, and all the code will be linked in the description and the Signals repo itself. Well, I think that's about good for the intro, so let's go ahead and dive in. So if you haven't heard of Signals, you can go over to pub.dev/packages/signals, and you will see the new library that I recently created. This is based on Preact signals and takes full advantage of signal boosting, which there is an article linked about that below. Signal boosting, in short, is a really cool way to have disconnected state based on a linked list. Now, other signals-based implementations use sets and arrays, and the problem with that is it's really hard to do out-of-order re-renders, and as the state grows larger, it can really start to eat up memory. But today we're going to be just going over how to build some examples with it. But if you still want to find this, you can go here, and this will have the documentation, which you can check out as well. So I'm going to go ahead and go over to the code, which we have up. Okay, so I'm going to start with showing you what we will be building, so that it makes it a lot easier to understand what we're going to be going over. So here we have the node-based editor. Now, we're not trying to do anything fancy with the design here, but I think it will show and get the point across. So I have a simple button down here, which is called Add Number, and this will create a new node on the graph. This is of a type number, and we can increment, decrement, we can reset the value to the initial, and we can even undo to the previous value. We can add multiple of these. And after we have that, we can now do some cool things with state. So if you select multiple, there's a blue border that gets selected, and create reducer and create if both pop up. If we have 3 selected, only reducer is shown, and that's because if only accepts 2. So if we deselect that, we can do create reducer and then drag this over. And what's cool is we'll have a drop down where we can do add, subtract, divide, multiply. You'll see this changes here over on the right. You can even select a reducer and a value, like a number, and it'll still work. And you see that this number gets passed through and all of that. And then we can also select 2 things and create an if statement. So an if statement is a little bit different, where you can choose how it is compared. So this is greater than or equal to, and as long as this meets the criteria, it'll be true or false. And you can see we can create chains of this. Now, you might be thinking, well, how would I build this with what I am used to? And the answer is it would be kind of difficult, and sometimes things like circular dependencies would be hard to account for. But what's nice about Signals is it supports up to, I think, a maximum of 100 calls in a circular depth before it will throw an error. So this is useful for when you do have cycles in the graph and you need to calculate that sometimes. So that's, I think, good for that. So let's go back to the code. And here we're just going to start off with the normal editor. The material app, and we're going to provide it a light theme with the default editor. we're going to go over in VS Code and create a new directory called nodes with, let's say, a base type. Here is where we're going to copy in the base node. Now, I'm copying the existing code because this video is really meant to be about walking through and kind of the commentary with it. And I think that this will be more than suffice, but you can see all of the code linked at the end. So here we're going to import material. We're going to have an abstract class with a generic input and output with the name and the list of inputs with a getter for the ID. And here we have the output build in size. Okay, so we can remove that. Here we can import our missing node and copy over the reduce. Again, we need to import material and go up here and import signals, as well as our base node. We have a T which extends number, and that's because if you're reducing in this way I built it, I only want to accept numbers. You could have a narrowed type of integer or double, and you could make your node editor depend on those specific types, but this will at least allow for all of that flexibility. So here we can set it up as the name, and it takes the list of inputs and then reduces it down to the value using a switch expression on the enum type. This build is for what actually shows up in the editor. So right here, when you see the different UI pieces and controls, that's going to be useful for having all of your state to be able to be updated and controlled and co-located with the node itself. We have a size variable that is dynamic because of the node's length, and that means that as we add more nodes, the height of the node will get higher, and that's because the multi-child delegate is expecting that. We can go in and import it there. Oh, we have two more. We can copy the if node, and I'm going to call this compare, which I'm going to change the name of it in here too. Import base. Compare node. Go in here. Change that. Import it. And we can copy the number node. Import material, import signals, and the base, and go in here and import it. Cool. So far we've just moved some things around and renamed stuff, but I think that is a good start. Next, I want to move out this node edges renderer, and we can do that by creating a new folder called widgets. Here we go, and import material again and the node type. Let's go and import it here, and let's copy out the node layout. Again, import material. We could import widgets, but I think it'd be fine to be consistent here. And let's go to the top. So if we want, we can hot reload and check to see if everything's working, and it is. Perfect. Let's go back to the code. And I want to walk through kind of more about what's going on in this view. So here, this is just an app bar, not doing anything special. And like I said, here's the watch widget. If you're coming to Signals for the first time and wondering what this special widget does, it's supposed to be a drop-in replacement for Builder. And in fact, if you do the new .builder, it will literally be a replacement. But it gives a build scope some superpowers. First of all, it still reacts to changes like theme and text theme and color scheme changing, or media, inherited widgets all changing inside the context. But second of all, it can listen for any Signal subscriptions, which can be dynamic. They don't have to be called at a top level. And it'll automatically dispose of them when the widget is done rendering. This will also check for outdated signals too, because Signals itself can keep track of disposed and outdated ones and remove it even before the garbage collector has a chance to. So that's pretty cool, but I think that should be a good explainer for now. And then I'm also going to just quickly change this because I think this will make a little bit more sense in the UI. Yeah, I like that a lot better. Okay, perfect. All right, so kind of going down into this, let's first start with the custom painter. Now, this is a stack, and this will be the size expanded, which will have our custom paint having the entirety of the background. Now, if you remember, we created this node edges custom painter. Now, I used a map signal to store the node with the given offset because I didn't want to store the offset with the node value directly. Also, I have this set of selected signals since it's either in the set or not. But by having those two pieces of state, that's really everything that we need to be able to render this. We can loop over the node entries, and we can grab the source value. We can check for its current size, which it provides, and we can get the center. In fact, I will do an optimization here because we don't want to render the size if it's empty. So I can do if it's empty, we're going to do continue, and I'm going to pull this out since it'll be like an early return. And then now this will only render once per loop. So we loop over the nodes. If the inputs are not, or if the inputs are empty, we will skip it. Otherwise, we're going to continue and we're going to grab the node. We're going to build its size, which is going to be the target, or the source that we're going to be building from, and we're going to grab the middle. Here we're creating the paint, and I'm just, based on if it's selected or not, we can change its color. And then now we loop over its inputs, rendering each of the targets, and then just drawing a line from one center to the other. So just to show what that looks like, if we add another number here and select 2 and then create a reducer, this line is going from this center to this center, and likewise over here. And then if I create another one and select these two and create another reducer, if you see when I select them, it'll actually select the lines in which is associated. But see, it won't select up because it's not part of its node. Just a small detail. And then if we go back over to our editor, we can see that as the child of the custom painter, we have a custom multi-child layout. Now, if you've never used custom multi-child layout in Flutter, it is super powerful. We have to provide it a delegate, which I'm going to go over in a second. But the other thing we need to provide is the children. And the children are the list of widgets that we're going to be rendering. And this is useful because we can put whatever we want here. It'll be, the size will be something that we're providing, just like we did earlier. And then we have to provide it this layout ID class with an ID that's explicit. Like I said, we already know the ID and we get that for free. And we're just going to pass that here. Just a quick note on what I'm providing as the child. Because this is in a custom multi-child layout, in the past you may be using a stack view with positioned and trying to put multiple gesture detectors and trying to pan them around. Now this can be pretty challenging when it comes to the way Flutter deals with the gesture arena. But what I like to do is a custom multi-child layout and using a gesture detector on the nodes themselves, because it doesn't matter if we provide a transform, for example, like where you're zooming at a cursor and all that, because the gesture detector will be picked up normally because this is following Flutter's normal layout. We're just having to take control of the size and the offset of the children. So here I can do multiple gestures together. I have a tap listener and I have a pan update, and this will be below any kind of controls that are added inside of the children. Here I'm building the stack itself, which is just calling the build method and then adding the label's name. Now I could do this as like a negative offset, and I could show you this real quick. If I were to do negative 10 and maybe left of 0. Not sure if you knew you could do this, but in Flutter, you can turn off the clipping behavior, or yeah, you can for a stack. And if we go over to our emulator, let me add it a little bit higher. Since we're not ever trying to render the children, or we're not trying to detect gestures of this, we don't have to actually care about it on the canvas. And so here, this thing will not handle touch events, but we can still include it on the canvas. I may or may not keep this, but I think this is pretty cool actually. So I'll put that here for now. So going back to the code, here we are just providing a different border and color when the selection changes. And like I already went over, we're just providing the child itself. So let's go to where we're building these nodes. Now you may be thinking this may have like a huge amount of code to do this, but it's actually pretty straightforward. You extend multi-child layout delegate, you provide it the list of nodes. Because I have each node in offset, we have everything we need. You need to override these two functions, which is perform relayout and perform layout. And this perform layout needs to run over each of the children, grab or build the size for each of the children, lay it out, and then position it. So it could not be more simple. We grab the node size from our getter, we lay out the child by its ID, and then we position the child by its ID. When this ID needs to match what we have over here, and so that's really important. But once we have that, it's just a matter of providing a size and then the offset value, which is what we have in the map. This is done every time that the watch method is called, which in this case is anytime the selection changes or anytime any node changes or any kind of update to a computed inside of that. But that's really it. And I think it's a really cool example of just with almost no complex stuff, you're able to provide this really cool state connected to other state and can be connected to itself, all with very kind of little effort. Next, I can kind of talk over like what are some of these actions doing. And so add number, which you saw, all it has to do is take the map signal, provide it a new number node, and then an offset. Here I'm just doing offset of 0, but I could actually do the center of the screen or the next logical place. And then I check to see if the selection is greater than 1, because we can't really do anything with one selection in this example I have so far. And then checking to see if every single of these is of type number, which is node dynamic num. We then can create a reducer. This reducer just needs an array, which we can cast. And then the first value to operator on by. And we just kind of clear the section. And the next one checks to see if we have type 2 in the selection, and then creates this comparator. So I'm going to change the name here. And we see we can grab the two nodes, cast them as their appropriate type, and create the compare node. And that's it. We can reload it one more time. And we can look at that. What's cool is I can select multiple, create reducers, and what's awesome is I like about it is you can add the values here, update them, and it'll tell you basically where they came from, and you'll see them in that list over here. This can even detect for divide by 0, but I'm going to set these to multiply and get some cool values. If you see, this can actually depend on itself over here. And it just kind of like is a good example of something that I've tried to build before. I've tried to build this exact example, but I didn't have the proper state to back it up. There was a lot of limitations with using either streams or value notifier or other options, and I was having a difficult time trying to build what I wanted to, and it could have just been I was doing the wrong thing. Please let me know in the comments if I am. But once I kind of figured all these missing pieces, I thought this was a good time to show this example. I just think it's pretty cool. You can check out the example in the description, like I said, and really looking forward to your feedback on this. This is, of course, a super simple starting point and not meant to be exhaustive, but I think it will be a cool thing to explore if you've never worked with a node-based editor before. Okay, that should be it for this video. Thank you so much for watching. Please remember to like and subscribe, and I will see you next time. Bye.